Thanks for joining us. We appreciate the opportunity to follow up with you after ProveIt. And Lenny, put you on the spot. What were a few of your favorite things about ProveIt this year?
Definitely for me was the Dumpster Fire Awards, Jeff. I really liked hosting that event. My first time being an MC for was anything like that, to be frankly honest.
Ah, you're a natural.
And I wouldn't say that, but I just really admired everybody showing their humility and just sharing those stories with us. And I mean, the reaction from the crowd was that everybody related to those stories. So that was really something special.
Yeah, no, I thought it was neat, and it's going to be a staple at Prove It events in the future. I want to give out as many of the golden dumpsters. I'm branding it the dumpsties from now on. So uh, I can't wait to see what stories we get next year. So Lenny, the audience is coming in, and I'm across 100 different monitors today. So apologies if I'm constantly looking away. But we're excited to get started. And so without further ado, let's go ahead and kick off. Today's going to be really just laid back, nothing too formal here for the webinar. Our goal is to walk you through four different use cases on why making your data decision ready matters. And we'll just kind of set the stage quickly with a few slides. And then, Lenny, you're going to do a lot of building today, if I'm not mistaken.
Yes, definitely.
All right. So, the very first thing just to kind of work through is that just like inside of your facilities and inside of your operations, you're taking raw material and you're producing a finished product. And in order to go from raw goods to finished goods, you have a very detailed process. You have steps, you have governance, you have individuals with specific roles to be part of making that finished good. Well, your data really is no different if we think about how we take it from data to information. I've heard a lot of people say that data is the new oil, and I think they're really accurate, but I don't think they're accurate, Lenny, based on what they're trying to say, right? I think what they're trying to say is data has value, and I would actually say no, data in itself doesn't really have value. Just like in my backyard, if I'd start digging to plant a tree and I'd hit a pocket of crude and it would start coming up into my yard, there's no value there. That's actually a hot mess. But if I'm able to capture and contain
And
and
refine.
then refine and then move and then power and action with that product, yes, now data is the new oil, but it's data is oil, information is gasoline, kerosene, plastics, right? And so if we think about prioritizing that transformation process inside of our facility, we have to focus really on where that's going to happen. And in order to take operational data and turn it into refined information, it requires a certain skill set. And that is not just someone who's able to navigate those steps, Lindy. It's someone who really understands the process, right?
Correct. It's a lot
So
of context that needs to be added from the process side on top of that data to then turn it into information at the end of the day.
that's right. And so that really starts to dictate in an architecture where this happens. And it needs to happen as close to the data, as close to the edge as possible, because that's where the process knowledge lives. And then if that's the where, then we need to answer the how. And so as part of this process, we need to make sure that we have certain priorities that we are focused on. That is governance, it's trust, it's collaboration, it's scalability. All of these things have to be prioritized, and they should be informing our decisions around architecture and our decisions around this process. So just quickly, I want to touch on five really important key value adds if you centralize your data transformation process. By centralizing it at the factory or centralizing it with your operations teams and isolating it, meaning I stop doing it every other place in my architecture. I'm not doing this inside of the application. I'm not doing this in the PLC. I'm not doing this in SCADA. I'm centralizing and focusing on one system to do this. You pick up independence. So you have now made yourself portable across many different plane architectures. I'm independent of historian vendor, of SCADA, of PLC selection, of MES. You're stable in this process, even if those platforms change or if the inputs into the process change. And you're removing yourself from being reliant on on those vendors and their tooling, meaning you might find a best-in-class SCADA package that you love for your operation, and you no longer have to ask yourself, how will it perform in a data transformation role? You can focus on the SCADA role. Collaboration. So the idea behind this is that many people have visibility into this process and that the tribal knowledge that those individuals have gets mapped into the process. Governance. Having our business rules live across many different places doesn't work. And a business rule meaning, how do we define key events? How do we define certain KPIs that run our meetings? What are our processes around data conditioning? How do we enforce that adherence? Now we talk about also how we scale or how we build. And so if we are doing our transformations in one centralized location, the work that an engineer just did is not lost. It's preserved, it's maintained. The structure of someone else's job can be reused in my current problem I'm solving. And most importantly, this allows me to start small and expand. I don't have to try to, in my friend Benson's terms, boil the ocean. And then finally, we have persistence. So in this process, all of the data that's transformed can now be stored. That means it's local and ready to be used by my people, my applications, and my processes. Ideally, not only am I storing, but I'm also versioning changes on those records. And I'm making sure that my apps aren't now having to rebuild these KPIs, these events, these data conditioning rules. Because if someone else rebuilds these rules somewhere else, I can promise they will not have the same result. Things will change. And Lenny, I know you've seen that firsthand as you've worked as a system integrator and you've worked with customers for over a decade. You've seen 5 different versions of the same KPI. KPI, am I right?
Correct. Definitely. And different data sources giving you the same KPI value as well. Those also change during time. So it's not just the KPI definition and calculation, but also where the data is potentially coming from
Hmm.
at the end of
Hmm. So today we're going to focus, Lenny, on just one of our tools out of our set. We will show AI Gateway just a little bit to solve a problem, but we're really going to focus not on Timebase and storing the data, historizing the data. We trust that you've already taken that step, but we're going to solve problems today using Infohub. And the reason we're going to use Infohub is because of the focus on where do we do this work of transforming data into information? How do we build an architecture that allows us to connect to all of our data sources and empower our people? So let's start, Lenny, with the automation engineer. What's the problem that the automation engineer wants to solve?
All right. So obviously, part of the automation engineer's job on a daily basis is he wants to analyze his process, right? He wants to analyze how the process is performing. He wants to create some KPIs and PIs on top of that process. And he wants to understand how external factors like different products, different shifts, different people all play a part within that analysis effort. Now, how did he do it in the past, or how is he currently doing it? Um, we still see a lot of people going and manually pulling data from historians, manually pulling data from SCADAs, manually writing values still down that they need to do and use within this analysis. Um, it might come from different systems. There might be data from the batching solution and data from the process historian that you now need to normalize and get aligned within a timestamp so that you can actually do your analysis accordingly on top of that data. They need to worry about the math. It might sound simple to do an average or a sum on top of raw data, but what if the counter resets to zero? What if there's a break in comms and you've got a null or a bad quality point? What if you need to perform a time-weighted average because your historian gives you delta storage? So there's quite a lot of challenges that we work with industrial data on a day-to-day basis. And a lot of the times, unfortunately, it's either throwaway work because they solve it and they move on, and it's not repeatable or visible to anybody else. We see the scenario where there's Excels with 500 sheets and different versions floating around on shared drives, and nobody really know which one, where to use it, and who actually maintains and has ownership of that solution.
So we're going to take that current state, we're going to flip it over, stand it on its head, and we're going to solve these problems for the automation engineer first, right? Um,
Correct.
you're going to really focus on modeling inside of InfoHub. It's funny because if you had told the 8-year-old version of me that I'd be working with models full time in life later, I would have been really excited about my battleships and my fighter planes and my race cars. But those aren't the type of models, of course, that we're talking about. But I do want to just quickly call out that for many of us still, when we think about models, we only really think about structure and relationship. We don't think about the greater piece of that model, meaning the model isn't just, hey, I have a piece of equipment and it sits in this cell, in this line, in this site. The models that we're talking about are rules around the inputs, the data that's associated with that line or that cell. It's around how we're going to cleanse that data before we start to use it. It's how we're going to look for events. It's how we're going to join tags from different systems, how we're going to calculate new results, how we're going to grab pieces of information from other silos and use it as context for the greater event that we've modeled. It's even how we're going to then take those events and do comparisons across different calendar periods or maybe do counts or mean time between events and further analysis. That's what the model is. And so the engineer builds these models inside of InfoHub. And because they're building them in this centralized tool, they're collaborative. Many, many hands get to be part of this. The results are going to be stored, and Lenny, you'll show that. I'm trying to preserve your voice just a little bit, Lenny. For the audience, Lenny woke up with the flu that many of us came home from ProveIt with, and I feel bad for you right now. So I'm going to try to do a little bit of your load there, buddy. We want to persist the results, and this is really important. So InfoHub has a SQL database backend. So everything that is modeled, the engines are then running those calculations 24/7 and storing those results so they're there and ready for the engineer. We handle all of the, I call them odd ducks, meaning, well, really meaning a couple of different things. Meaning, what happens when data arrives late? What happens when we've already calculated things and somebody goes and changes some of the context around it and now it needs recalculated? What happens when I've got 5 skids that are laid out one way and then I've got this 6th skid that's completely different? Well, all of that is handled within the product. And then you get to actually take these results, and we give you a lot of different ways to share them with the team. Today, I think, Lenny, we're going to show some visualization options for
Yes.
an automation engineer. You ready to take a quick just overview architecture wise? We've got data silos, right? So pull the factory roof off and look down inside, and you'll see not just a circle that says data, but you'll see areas that have different systems. Historians, MES, CMMS, LIM systems, business systems, maybe some ERP data. There's sometimes dozens of these systems inside of a plant. We're going to maintain connections to those that are important for our models. And you're going to be working inside of InfoHub, Lenny, so that you can then provide the history to your engineer.
Exactly.
Okay, you ready to go?
Perfect. Let's do this.
Let's see. Does it
Right.
make me
So
stop or can you just take over the share?
uh, I can just share. There we go. Perfect. All right. So Jeff already mentioned that we've already historizing the data, right? So I just want to run through the use case that we're going to tackle today. So what you're seeing in the screen is our Explorer tool within the Timebase historian. And I've got the history of the data that I'm now going to analyze and slice with our different process values, as well as our different process steps. So the need that we want to achieve here is we want to do an intensity calculation. So we want to know per product and per machine state and per time period, what is our intensity of water usage per unit, as well as our electricity usage per unit. All right, now what you see at the screen here is my energy. So this is my just kilowatts that's been drawn by the filling machine. And you'll notice, obviously, if I want to know what was my total from 8 o'clock to 9 o'clock, I need to slice the data with that piece of time. But I also now want to know, okay, but what is it when I'm in a cleaning state or a CIP state? So I need to be able to slice the data with that. Am I using data that I shouldn't while I'm in my idle state? So I need to be able to slice it with that. So not just with the slice of a normal calendar time period, I also then need to slice it within that specific hour. I've got three states here. I've got a running state, a breakdown or a bottle state, as well as a running state. And I'm going to do that exactly the same for my production. Production is a lifetime totalizer. Again, I'm going to not only slice it by time, but I'm also going to slice it in this case, potentially per the batch. So what was the batch that was running and what was the product that I'm actually manufacturing in this case? So I'm making orange. So all of these different contexts that I'm adding to this data, I'm going to slice it within Infohub to give me exactly those answers that I need to know: intensity per hour, intensity per product, intensity per machine state, intensity per batch. Right. So that's the frame of
Lenny,
what
can
we.
I real quick just interrupt you because on my side I don't have your screen share, but it's probably just the fact that I've got my environment. Can I ask someone in the audience to use the Q&A and just confirm for me that you've got Lenny's screen share coming through? Okay, we see it. Hey, oh, hey, whoa,
Oh,
geez, very helpful. Thank you, everybody. And as a reminder, we are giving away the Lego. I forgot to say that at the beginning. We're going to do Q&A at the end, and then we're going to do the Lego giveaway. Okay, cool. I don't need to see your screen, Lenny, because I think I know what you're doing, but I'm glad they
okay.
can. Please continue.
Perfect. All right. So as I said, electricity, water, same thing. I'm going to slice it with the state, and we're going to have these different time slices that we're going to work with. Right, where I'm going to do this, I'm going to do this in Infohub. So I'm going to move over to Infohub, which is now our modeling solution. Right, so on the left-hand side, you'll notice that I've built a little bit of a model. As Jeff mentioned, yes, part of modeling is to have this hierarchical structure of my KPIs and my pieces of equipment and the PIs that I want to monitor against that. So you'll notice I've got a filling line in my site, and in that filling line, I do have a filler. And you'll notice that I have these different metrics that I've modeled here. But how did I actually do that? So let's build one from scratch. So I'm going to build my own little filling line within my structure here. So I'm going to create a new folder within my model, and this is just going to be filling line number 2. Perfect. All right. Now, I need to be able to identify changes in time, hours, days, weeks, so calendar-based context, but I also need to be able to detect changes in machine state and machine work orders. And the way that we do that is by utilizing events. So event is going to go and track the changes in the state, going to track the changes in the batch, and that's then going to give me that context to slice the data according to that event frame or event time. So I'm going to create 2 events. I'm going to go and create a filling line 002 state event. This is going to track the different states or the machine states that my filling line goes into. And I'm also going to go and create a filling line 002, and this is going to be my product run. So this is going to give me the context of product that I'm manufacturing, as well as the item, or the batch number, the work order. So there's my 2 events. Now, obviously, I need to be able to detect when these things change. So when does the machine state change? When does the work order change? And the way that I'm going to do that is I'm going to use what we call a tag. A tag is the raw representation of the history that we're going to pull from our different data sources. And I'm going to utilize those changes in these states and the changes in the batches to actually trigger my events. So let's do that very quickly. I'm going to create a state tag that's going to reference the state changes with that machine. And I'm also going to go and create a product run or a work order change event as well, or tag that's going to track that. On my event, if I open that up, I'm going to use these tags that I'm referencing, and I am going to trigger my event based on that tag. And that is as simple as taking the tag from the model, dragging it into the trigger section here, and say, you know what, I want to change either on a specific condition, or I want to actually trigger every time that state tag changes. So that's definitely what I want to do. So I'm going to change my trigger condition whenever that state changes. And I would potentially also like to know what was the state, right? So I'm going to add a little piece of metadata to this event, and that's going to be the state of the machine as well. So I'm going to expand my attributes here, and I'm going to go and create a retrieved attribute. Again, we're retrieving it from the underlying system that we're going to connect to, and this is actually going to be the state from the machine. And again, I'm just dragging my tag from the model onto that state as well. The state of the machine is an integer value that's being stored in the machine. I can enumerate that to actual value representation. If we look back at the historian, I would like it to say running, cleaning, idle. I don't want the integer representation of that. So I'm going to go and create a enumeration lookup for that as well. Now notice while I'm building the model, I'm not caring from where it's coming from at this point, right? So the important thing is I'm modeling what I need to analyze, and then we'll care about where we're hooking it up from a data source perspective. Let's finish off the work order. It's going to be exactly the same. I'm going to trigger my production run based on any changes within my work order. So I'm going to do that when the value changes, and I'm going to go and create a attribute that's going to be retrieved, and this is actually going to be my work order. Oops, work order number. Perfect. And again, I'm going to use my tag to reference that. I also would like to know what is the product. So not just the actual batch ID or the work order ID. I also want to know what the product is. So I'm going to extend my event here to also give me the actual product that I'm manufacturing. And again, I'm just going to extend my event to have that product as a attribute as well. Use the product tag from there. And again, I want to be able to say it is, if I look back at my historian, I want to be able to say it's orange or apple or whatever the different products is. So again, I'm going to go and enumerate that with my product enumeration as well.
So Lenny,
Perfect. Yes,
the idea being now that later on when your inputs, when your data is mapped or bound to these definitions, when your trigger happens, right, the our data engine then knows where to go ask for the attribute information and
correct.
then write it as part of the event record.
Correct. And it will store that as part of the event record. And I'll show that how it persists that value when it runs through it. Perfect. Thanks, Jeff. All right, so I'm happy with my two events to track machine state and product. I also now obviously have to track my water usage, my throughput, and my energy. So let's quickly do that. I'm going to use a metric. So I'm expanding my model with a metric. A metric is the what? So what am I measuring? I am measuring filler 002's water usage. So that's my first metric. I'm also going to go and do filler 002 electricity as an example.
You got close,
And
almost.
almost. And I also want to know filler 002's throughput. So how many bottles do I actually manufacture from that perspective? Cool. Again, I'm going to use tags. So I'm going to have a raw tag that's going to be the actual for my water usage. I'm going to have a raw tag that's going to be the electricity actual. And I'm going to have a raw tag that's going to be my throughput as well. All right. Now, if I look back at my historian, I can clearly see that energy is the raw kilowatt hour meter. Throughput is a counter retrieval. And again, water is again the liters per second or liters per hour that moves through the line. So that's going to guide me on what type of aggregate I need to perform on this.
Hmm.
We spoke about time frames, fixed calendar time frames, hours, shifts, days, weeks, months, quarter, years. So I'm going to take my tag and I'm going to drag it onto the hourly icon. And that is then going to give me my hourly my hourly water usage, and just to show that we're going to leave it as the standard time weighted average because that is then going to give me the actual total for the hour. So I'm going to leave it to that.
And that average you said is time weighted. So we're gonna, if there wasn't a change for the first 3 minutes of that hour, we would look back at the previous boundary value and carry that previous
Correct.
value.
Exactly. Yeah. So our average calculation on this level is a time weighted average
Yeah,
as
that's
well.
one of those things that you work with this system long enough, you just take for granted of the amount
Mhm.
of work that that is to handle if you're not using some type of a governed aggregation that understands how to do that.
Exactly. All right. But we've got not an issue, but at this point, the only context that we had is the context of time, which
The
is how
hourly.
our
Yeah.
code. Exactly. So we need to add the context for our state,
Hmm.
and I'm going to also add the context for my product runs.
Because you want to know in that hour, maybe I crossed across two different events. Maybe I stopped, moved out of one state to the other, and you want to be able to split across those states so you can then take these hourlies, I assume, and bring them up into like a daily total or a weekly total by event type.
Exactly. So I want to be able to slice it not per the hour, but yes, in the middle of the hour, if I've changed from CIP to normal running state or to idle state, I want to track exactly that
Hmm.
point, and I want to be able to slice that data with those little time slices as well.
Yeah. And I often hear that from engineers that this is a key feature for them because to get a running average or to understand the condition for the last 15 minutes, not hard. But
Yes,
to be able to then contextualize that across all of the different products, all the different SKUs, all the different work orders, all the different states, and then do that analysis. I mean, from what you're demonstrating, it's literally just dragging those defined events right into the exact same calculation that's going to give you your hourly or your daily or your shiftly numbers.
exactly. And don't forget about the other metadata that's associated with it, right? So we
Hmm.
need to fix our unit of measure. So it's going to be the total liters that I'm producing. If we talk about AI going in the future, it's giving nice descriptions so that the AI know what it's looking at, right? So I need to say, this is my water usage for filler 002 as an example. So the more context we add to it, the more and the better it's going to be for external systems, apps, and engineers that's going to work with the data. And I can also go and associate what we call model attributes, right? So model attributes can be stuff like to which enterprise is it linked, to which line, to which vendor, to which work center is it associated. And again, this is all metadata that now lives in the model as it gets executed in the model as well.
And I don't expect you to go into it, but I see there's also limits. So you could do thresholds, you could do targets. Yeah. Okay.
Perfect.
More context.
Exactly. All right. So I've done the water. I'm going to go and move a little bit quickly to do the electricity. It's going to be the exact same thing. So I'm going to
Hmm.
drag it again onto my hourly. We know it's a time weighted average, so I don't even have to worry about that, to change that. So the only thing I need to do here is obviously fix my unit of measure and add my context to my different items. So let's do that. So that's going to be kilowatts. And let's just go to the context and quickly add my product run and my state.
Yeah. And for those that are seeing Infohub for the first time, you may not be aware. There's all of these model rules that you're seeing him build can become templates. So if you're thinking, I've got 22 lines and I want to, you don't build this 22 times. You build it once and you instantiate it 21 times. So you're just seeing the effort on the hardest part, which is the original model build out. And I hope what you're seeing is that there's a lot of just drag and drops. You're not seeing a lot of script here. You're not seeing a lot of code. While we do offer that capability, we could absolutely use the bottom function of that element zone, the calculation, and you could build C# expressions, use user-defined functions. You could go crazy in building really large, complex structure here to be able to get to what you need. But for this use case, he doesn't really need to do that.
The only thing that I want to show, Jeff, is that little pass that we talk about in the model. If I want to clean data, right? So what
Hmm.
I'm doing here is I'm saying, if my quality coming back from my historian source is good, 192, which is the good quality code from the OPC, then return the value as is or null it out so that I don't use bad quality within my aggregations. Just going to validate that calc. And now this is the calc that I'm going to use to then define my hourly value at the end of the day. So I'm building those cleansing rules within the model as well. So it forms part of the execution of the model at the end of the day. Right. So remember, this is a counter aggregate, so we handle the rollovers because my good production is going to be that counter value. And the last thing that I need to do is just very quickly add the context for that as well. Product, and there we go. Right, so I've got that all sorted. The last thing that I need to do is to do my intensity calc, to be honest. So let's very quickly do that. So this is going to be filler 002 in 10 intensity. I'm just going to do one of them. So let's take the throughput. Let's take the hourly total of products, drag it onto my calculator. This is going to be my water intensity. So let's move that underneath my intensity metric. So I've already got the total production because I used the throughput calc or measure to create the calculation. This is going to be liters per unit produced. I'm going to take my water usage for the hour, and I'm going to say, what is my total water divided by my actual total throughput? And there I've got a very simple little, and again, it will do it for the context as well. So it brought the context of those across as well. There we go. So there's my model. I've built out my model. It's not operational yet, but I've built my model. And the only thing that's left for me to do is now to say, okay, all I need to do is to say what data source is the data coming from.
So at this
All right.
point, Lenny, you've spent 10, 15 minutes. You've built a model for your filler that
Yes.
is going to give us throughput, water and electricity usage. It's going to monitor for state changes in the process, and it's going to account for batch runs, assign those batch runs with a work order, with the product we are making. You're going to pick up the knowledge of which state in the state events. And then you're also going to turn all of those hourly measures to be contextualized by those events in those states. And if you wanted to spend more time, you would turn those hours, maybe just for one of them, you'd roll those hours up
Today or
into a daily or into a weekly. Would you do a day to date on just one of them, just so that?
I will. So let's quickly do this. All right. So all I'm doing now is I'm saying, oh, for filler two, there's my state tag in the historian. And I'm
Okay,
going
so
to
you're
say,
browsing the historian namespace over on the right-hand side.
for that tag. Let's refresh, and there we go. There's my raw data view for that. If I give it a little bit more time, we can see how that changes through time. So there's my different states. So that's done. Let's do the product and the work order quickly. All I'm doing is I'm associating it with the product. So this is product. There's filler two's product, and let's do the work order.
And Lenny wouldn't care where this data lives. This could be coming from an MES system or coming from another record. It could be manually entered by a frontline worker. Um, this is completely abstracted from the source. So you can use 5 different data sources and bring them into the same model or the same measure.
Right, so I'm going to do the last three very quickly.
Yep.
So the first thing that we've got is the throughput. So that will be filler two's good production. So there we go. There's the good bottle count for filler two. Second last one is the energy. So there is the energy for filler two power. Associate that. And then the last one is going to be the water. Yeah,
Now, could you imagine with these tag names just arriving into the enterprise in their existing format, raw format, someone trying to understand what 131FT-002 represents and building a model off the plant floor? I, this is why it's so important that the subject matter experts are part of this process.
correct. Right, I'm going to deploy it, Jeff. So that means I'm operationalizing the model,
Okay.
right? So I'm done building it. I'm not putting it in production. Now the model is live. So it's going to do my calcs. It's going to do my contextualization. It's going to do my my calculations, do the versioning, etc.
So
You
come
wanted
back,
one date?
everybody, in an hour and a half at the end of the next hour, and we'll have our first data point, right?
No. So we're back full, so we can look at historical data. So let's see if I look at my throughput, if the engine has already calculated those values for me. So I've backfilled till the end of February. So there we go. There's my total count. So I've got now context for the hour. I also have context for the product. I've
Hmm.
got products for context for the work order. And I also have, obviously, when there's a change in this hour, I have two work orders. So
Hmm.
that's the slicing that we spoke about, that now
So
I've got that
hang there for
difference in duration for those values.
hang there for just a second. So if we look at period start, the 2 o'clock hour through period end, the 3 o'clock hour, you had work order ending in 30, and you had work order ending in 53.
Yes.
And then for this is a filtered throughput. So this was for what? Our total production. And
Yeah.
then
Correct.
you've got different durations for that production, I see. Okay.
I think I lost Jeff there.
Oh, how about
All
now?
right, Jeff, I'll come back to you when you get back. But you can guys can see that we're slicing it per order and per that for the different. Sorry, Jeff, we just lost you there for
Am I
for a few.
back? Are you seeing me?
Yes,
Okay,
cool.
great.
All right, so that seems to work. That's all working. I've done that for filling line one a little bit earlier as well. So if we look at the intensity calcs for that, we can see that that did exactly the same thing. This is now persisted within our database with the quality score that we get from the underlying source. And I can see for the different states, different work orders, I can see what my intensity calculations are for that. Let's just add a little bit of format. There we go. And then we can see whenever we utilize, there we go. We've got some intensity there. I've already built a dashboard for this. So there we go. I've got a dashboard here showing me my accumulative total. I've got a dashboard now showing me my energy and liters of water per state. Interesting enough, when I'm in my idle state, I utilize quite a lot of water, so there's probably a little bit of an issue there. And then I've done exactly the same for my work orders. So I've got my work order runs, the work order, the product that's utilized. When you see water, that's the CIP stage when I'm only using water to clean out the line. But there I've got slice per state, slice per work order, and then I've got my total production as well. I've done a different calculation here as well. My hour over hour index, that just tells me from the previous hour till now, am I seeing an increase or a decrease in my production? So that's quite a big increase there from the previous hour. So that looks a little bit suspect. I would like to see a little bit more just calm. I mean, it's almost double the production of the previous hour. So something either went wrong in the previous hour or now. So I can drill into this calculation. I can look at the details of that calc and I can see what the value was that was fed into it. And if I drill into that, I can even see the data that's coming from the historian. So yes, clearly I can see that my previous hour, I had a big chunk of time that didn't produce anything. So
Right.
yes, I am going to see a big jump in my hour over hour index. Let's flag that. Let's add a comment there to say I don't like the sudden jump in this PI. Seems we have reliability
While
issues.
you're doing that, Lenny, there's a question I'm going to answer real quick
Yes.
around products enumeration. So we have a little toolbox where Lenny just created a mapping ordinal pairing of the int values to their products. Um, and he called that when he made his enumeration selection on the dropdown of the events. You could also link to an external database for that.
Yes. All right. So now I've added human context as well. Just another little piece of context to the data as well, Jeff. All right. I think that for now, we're running a bit short on time, but I think for the
Yeah,
process engineer or automation engineer, that was quite quick to get his little utility operationalized and going.
yeah. And that's a 20-minute effort on that dashboard. Maybe, well, actually, you've got a complicated dashboard. Let's call it maybe a 2 hour effort on that dashboard. But to just create a table, that dashboard table, 20 minutes, you'd be
Yeah.
able to solve that problem. Let's pop back over real quick, Lenny. I'm going to pop over to tee up, and the next couple use cases I think are going to go a little fast anyway.
Yes.
So I think we're okay there. I just have to figure out where I'm actually sharing. 1 second. And there we go. Okay. So let's talk about our application engineer. So they need to grab ready to use information. We are trying to govern the way that this data is processed. That means that you can't then go and build through a bunch of custom code everything that Lenny just did and bury it inside of an application where it's never going to be seen again. Because we want our people that are consuming the data to have visibility, right? So, current state, application engineers are spending a ton of time with point-to-point integrations, trying to figure out how to get data out of legacy systems. They're trying to figure out if they need real-time data or if it's historical data they need, whether the process knowledge is actually in their heads to do the transformation. And they know that the more code they write, the more technical debt they build, and they're scattering it across multiple applications that aren't going to stay in place for as long as the operation probably thinks they will. People change out their reporting suite, they change out their dashboarding, they change out their BI tools. So Lenny's going to quickly show a way that we can stay outside of any one platform, build an application where you want to build an application, but trust that the data that you're retrieving is already transformed information so that you don't have to go through and embed process knowledge or have to worry about doing the transformation process inside of the application. Lenny, what are you going to use for this? What's your app of choice?
Cool. So I'm gonna use Ignition for this.
Okay.
And I'm going to use open standard technologies to integrate kind of between Infohub and within Ignition, where I'm going to build my application.
So Ignition, when you're saying you're using Ignition, you're just using Ignition as your pane of glass. You're not
That's
using,
single source of just
yeah,
visual from a visualization perspective.
yeah.
I'm not doing anything calculation wise. I'm looking at just the data that I'm getting.
Okay. You want to
All right.
switch over to
So
your screen? Let me stop my share. There you go. Now you can take it over. Thank you.
cool. Perfect. All right. So we ended off with creating our intensity calcs so we can see our different intensities for our different states and product that we're running. How can I now share this information out with other applications? I'm not talking just Ignition, right? So we want to use open standards. So we've got the capability to push this out with MQTT, or we can get the data with the REST API as well.
Hmm.
So I'm pushing out two sets of data into my MQTT broker. So I've got real-time data. Right, so this is the real time as current state of the data that's getting from the plant. So I can see what my counts, my defects is, but obviously there's problems with that, right? I don't know what the units are. I don't know what the context is. I don't have history of that data. It's great to show you the current state, but we need a little bit more if we really want to make informed decisions on that data. So you'll notice that I'm pushing out data to my little flow topic here at the bottom. And that will now send me all of this rich decision-ready context that I've just built out through my throughput. So there's my hourly outfeed, there's my total. And now you can see we've packed in a lot of metadata with this value. I can see what is my name. I can see what is the units. I can see what is the description of it. I can see that this is for the past hour. It's the hourly interval. Where does it live in my model based on the hierarchical structure of my model? What is the format that I use to visualize the data point? But this for me is the most important part, is we give you the API endpoints to pull the history for this point. Because remember, the MQT or the broker is just going to give you the current hour's value, right? With all
Right.
of this metadata. But if I want a trend, I want to see some history data. So that's very important. Obviously, we give you what was that hour? That was for the past hour. What was the shift that was running while we were doing this? And then we get to the values, right? So it's not just the current hourly value, but it's also now the value sliced per
Hmm.
product. It's sliced per work order. It's sliced per machine state. It's sliced per bottle jam.
Everything
So
from your model.
Everything from our model is now contextualized within this packet. All right. Now, what did I do within Ignition? Well, within Ignition, I've done something very, and that's a great time. Anyway, in Ignition, for the trial to end, what I've done is I have created a connection to that broker, and I've created what we call a custom namespace. So this namespace here will pull any tags based on a JSON payload, and it will pull it into the Ignition time-based setting. So if I go to my designer, we'll notice that I have a new folder within my tag browser here, which is called the Enterprise UNS. If I browse it, I can still get to the real-time value. So if I just want to know what is my current count, I can add that to the screen and I can see there's my current counter value for that. But if I look at my flow metrics, I now have a whole bunch more of
Wow.
metadata. So let's look at my throughput. Let's look at my outfeed and let's look at my total outfeed. I now have data around the measure. So I can now say, you know what is the interval type? Oh, it
Hmm.
is an hourly measure. What is the unit of measure for the UOM for this? Oh, it is total of units produced.
Hmm.
What is the parent or what does it live? What is that API endpoint? So what is that endpoint that I need to hit to get the historical data? So all of that is available. And then obviously in the values part, I've got the actual raw value that I can now also add to my screen here. So now I can say just use a LED display, whatever the case is. But there I've got the current hourly units of total production,
Wow.
right? And again, I could have gone and look in the array for what was the current product that we're making. So all of that data is now also available within the Ignition tag picker, which is great. Now, I would like to use this in a chart because I would like to be able to historize this history, right? So I'm going to go into my perspective component here.
Or
And
view the history, right? Because it's already
correct. So
historized. Yeah.
it's already, sorry, it's already historized. I just want something to visualize that. So
Mhm.
I'm just going to use the time series chart within perspective. So there we go. And all that I need to do is now bind it to this endpoint, this
Hmm.
HTTP endpoint. All right. So I'm going to do that quickly. I'm going to go into my series. I'm going to bind to this data point here. It's going to be an HTTP binding because I'm going to use that URL. Now I've got a little cheat sheet here at the side just to make this a little bit easier for me. So I'm just going to copy my URL here.
What's crazy to me while you're doing that, Lenny, is that your apps engineer, who's a specialist in perspective, now just has this incredible rich feed of data to build from without having to understand, without having to go build build that inside of Infohub, right? It's just made available to them to go.
Exactly. Um, I'm just quickly adding our authentication. So we do have bearer token authentication that we utilize for this. And there we go. I can see that I'm getting my data back. The only thing that's left for me to do is to properly format the data so that it will actually work within the trend. So
Hmm.
I'm just going to add a transform script. Again, this script does not do any calcs. It does not do any of that. It literally just transforms the data into rows and columns for the trend to be able to use that. So let's hit apply there. There we go. And there it is. There's my historical data within the trend. If I play it, I can even go and change the date range here. So let's change it from a few days back. And there we go. I can see my historical data as it's pulling through.
You backfilled up until just the
The
20, like the
28,
28th or
exactly.
something. Yeah.
Um,
So you could be in Perspective, you could be in Power BI, you could be in, I mean, really, it doesn't matter. It's your process is now standardized on how you get the information for your applications.
exactly.
Okay. Should we
How did
put
I
that?
do that within InfoHub? I have concept of retrieving data from the source, but I also have this concept of pushing it out to an integration point.
Yeah.
And that's when I'm pushing it out to the MQTT broker
Yep.
with a topic format. And we've got a special um, profile that we utilize to make sure that the packet looks the same every time, all the time when we're pushing it out.
So our third use case is for the enterprise architect who has to also figure out how to get all of the data off of a site and into, say, their data lake or to whatever data stream is necessary. And sometimes that's multiple data streams. Without you having to stop your screen share, do you want to go ahead and just show us how you solve that problem? So let's, you know, it could be
Sure.
Snowflake, it could be AWS, it could be Azure, Kafka. Where do they, where are they taking the data?
So what I've used for this little demo is I'm using event hubs within Azure. Event hubs gives me then the flexibility to make this data available to a peripheral source of data lakes. Think about Databricks, think about Azure itself. Event hubs is just the landing place, and then it's made available for a lot of products within the Azure space. So I've created a little event hub, and I'm pushing data to this. So I can click on this little data explorer here, and that should show me all my messages when I'm pushing that out. Again, within Infohub, it's literally as simple as taking my Azure Event Hub consumer and adding that to, again, the same way that we're integrating back to MQTT, we're going to use that same push methodology to push it out to the Event Hub. So it's two streams of the exact same data that we're going to push. I'm going to deploy that out. Again, I've got control over the payload and how that looks. I'm going to deploy that out. That's I'm going to start sending it to there. And if I'm lucky and I start to view all the elements within my hub here, I should see at least a few messages coming through. There we go. And again, if I click on that, there we
Hmm,
go.
there it is.
Description, totals, parents, production, the instance, the data, the values, and the states, all the different attributes that's coming through with this packet as well. So now all of that being contextualized on Edge is automatically made available for the data lake of choice within the higher enterprise solutions as well.
And it doesn't just go to, you don't have to just pick one spot. That data consumer integration engine that Lenny's talking about would allow you to publish to a Sparkplug broker. Of course, you saw MQTT, but you could also write to other databases. So you could
Yeah.
push this data into another SQL database, into a Kafka stream. And additionally, there's another engine for messaging where you could put it into a Slack channel or an email or a Teams notification or a Teams channel. So lots of different ways to share this information depending on the architecture that you need. Lenny, let's do this final use case. So final use case, plant leader. You're a leader at the plant, maybe you're a manager, maybe you're an engineering team lead, and you're used to having to have dashboards built for you, or you're waiting for reports to arrive. You don't necessarily have maybe either the permissions or the skill set to just reach down into databases and query data, or frankly, you're probably too busy to be doing that. So you've been limited by what's on the page or on the screen in front of you. And worse yet, numbers don't really tell you the emotion of your people that you're leading. So we want to show a way that we can go ahead and use the AI Gateway, which is our MCP server that has all of the tools you need pre-built and ready to go to be successful so that you can actually interact with this data. This would work for any environment that has an agent that supports MCP. So we're not including an agent with the product. You wouldn't want us to. Your IT wouldn't want you to. So if you're using Claude, if you're using Copilot, if you're using Gemini, if you're using your own local model that supports MCP, this will work for you. Lenny, you want to walk us through?
Perfect. Yes, so this is Claude Code that I'm utilizing. Again, it doesn't matter which agent it is. Uh, if I give it a command to just show me all the MCP tools that I'm connected to at this point, I'm going to go and hit that. Notice that I'm connected to my Infohub MCP server there. And if I look at that, let's look at all the tools that's available. So it tells me I've got 22 tools. So let's view those tools. So there's all the tools. Again, it's tools to search the model, it's tools to search the folders, it's tools to get the measures and the event data. It even gets the raw tag data from that underlying tag that we're pulling the data from through the story, and it will be able to look at that. Again, very important that we get our calendar context correct. So hours, days, weeks, years. And then obviously the measure data per calendar, the measures, the calendars per shift. So we've really went and created all the tools that we feel is required. We maintain the tools, we maintain the description of the tools, so that try and minimize tool usage and minimize the context that you're going to utilize. So if I look at one of these metrics, it's already defined. It's got a description. It's got the purpose of what the tool does so that the agents know which tools to run and use at the end of the day. Yeah, so that's all the tools that I've got that I'm going to use. So as Jeff said, I am a manager. I want to very quickly just understand, do I need to be able to be, am I concerned about line one today? Right, so I'm going to ask it a very simple question. I said, can you look at that hour-to-hour index ratio for line one? Should I be scheduling a meeting with the team? Look at the past 8 hours, please. So I just got on the job. I want to see the past 8 hour shift. And I just want to understand, how did last night's shift go? Do I need to have a serious intervention with my team or not? So I'm going to run that prompt. It's going to go and utilize the MCP tools to get the data. It's got quite a lot of data that it's pulling there. And then it's going to run through that data, and it's going to go and give me a little bit of a recommendation, or should I be concerned? Remember when I said that hour-to-hour index looked a little bit suspect? It jumped quite a lot in that first hour. Let's see if it actually finds something there to see if there's some data that we need to look at. Okay, so it's going through its things, and let's see what it does at the end of the day. All right, almost there. I'm not running this model at locally. It's still running in the cloud. I'm just pointing our MCP tool results to the
Hmm.
LLM that runs in the cloud to pull the data and give me that recommendation. There we go. All right. Yes, there's two separate concerns that has an issue. So definitely there's a spike in that over to hour ratio. Um, so it's trending upwards right now, or that your defect rate is actually trending up. So you are starting to make worse products. Um, so there's definitely an operation, and it gave me recommendations. So first thing is I need to have a meeting with operations and QA to get an eye on this. Then also have to schedule maintenance engineering to understand what was the massive stoppage in the morning's data, and then make sure that at the end of the shift that people understand what three metrics to look at to see if we can do that. I've done it a little bit earlier as well, and what it actually did do was it actually brought that comment from the user um,
Mhm.
through as well to understand. Listen, the team's actually frustrated with that as well.
Hmm.
So that's where it brings in that little bit of a human context for you to give you these little bit of
Yeah.
recommendations as well.
Our goal is to really enable this technology as it becomes more reliable over time. But for now, it's, I think, super helpful to, as you're building models, to think about leaving context and leaving the information that AI would need to be successful, even if you never leverage AI, because you'll become a better modeler by doing so, right? Well, Lenny, thank you. I think we hit all four of those use cases, and you left us time for more questions. Before we hit the questions, we'll stay on for as many questions as you have. Before we hit the questions, I do want to go ahead and get that Lego giveaway done, because I know that there's at least one of you or two of you here that have just been messaging me nonstop about, hey, make sure I get this thing. So you know, that's not the way this works. Um, Instead, we are going to keep this as transparent as we possibly can. So let me get us to, we'll come back to that. Let us get to the link that I need. Lost my mouse. Still lost my mouse. All right, we're going to do it the old-fashioned way, Lenny. I've got, where are you? I've got all of our participants that have registered sitting here with their names blacked out for privacy. And somewhere around here, I have got a random number generator. We've got 110 people that are in on this. And Lenny, the very first thing I'm going to ask you to do is we're going to figure out how many times we're going to spin, or how many times we're going to hit the generation button. Okay. So let's spin the wheel. So we're going to take the third number that we generate. There's the first, there's the second. Drum roll, please. 17. Who is our winner? No, Phil. Brita Considine, you just won yourself a Lego kit, and I am guessing I've got a shipping bill because that sounds potentially like that one might go to the Netherlands. Bradis, go ahead and shoot us a note and get a hold of us, please. I will shoot you an email on the backside of this as well. So, Lenny, let's get back to the questions now. And to our dear friends named Rafi, who did not win the leg. I am so sorry, buddy. But hey, you've already got one of them. You know, you've got the NASA. You had the Artemis, which I thought was pretty cool. All right. For our audience, thanks for hanging on. As we do the questions, if you'd like to have a personal demo, if you'd like to go ahead and make a plan for a pilot, if you'd like to talk through what a trial license would look like, please go ahead, scan the QR code and take action with us. That QR code is going to get you to my calendar. It'll also get you to the ability to say, hey, I want to go ahead and take a series of different actions. We'd love to help you with that. Rafi, good sport. Rafi says, congratulations. Um, is there a Lego giveaway bonus on top of the awesome session? Thank you. Yeah, we love giving away Legos. I think that's something that many of us have a passion in common. So there was a question, Lenny, around do we support um, AMQP publishing for something like RabbitMQ?
No, not yet.
Okay.
But the way that we've built the product is it is a plugin architecture. So what that means is that we can very quickly spin up a consumer, the one that I've dragged to push that data out. And that would be able as you don't have to reinstall the entire product or that. We just load that module essentially to enable that functionality. So I will definitely add that to a feature request for the dev team.
Okay. And Bryce, feel free to reach out to Lenny or I to talk through that use case a bit more. If you'd like, if you've got a problem you're trying to solve right now that needs that, we can help prioritize. Um, Sherman asks, what is the technology stack? So Sherman, the only real technology stack that we showed today is Flow Software's Infohub. Infohub is a complete separate piece from your SCADA, your Historian, your MES that is used by the plant to pull data from those systems, build these models, and then publish all of this information you've seen to these other applications. So today, Lenny showed applications from Ignition's perspective, an Azure Event Hub, MQTT
MQTT,
Explorer for a broker.
but
But yeah.
that's all just the external application that gets or consumes data from InfoHub. So the only two really stacks from our technology that was utilized was obviously Timebase Historian to get the historical data records, and then InfoHub that did the modeling and the
Yep.
execution of that model.
Lenny, can you go back to screen share for me? And will you and the audience, you can just tab over to Lenny's tab at the top of the page. Um, and because the next question is, how did you project all of your contextualized data out to a broker? Will you show just maybe the payload on the data integration?
Cool. All right. So I'll just close there. Okay. So on my MQTT consumer, we've got different versions of protocols that we kind of support, right? So the one is you can either push it out your own custom payload, and you can define the payload structure as you want. Or you can utilize what we've done is called a SM profile or smart manufacturing profile. So the smart manufacturing profile will automatically structure the message within the way that you've seen it in the broker. So you'll notice that we have right at the top of this namespace, we've got a URL link to our actual documentation around how do we define this schema or this JSON schema. So if I copy that and I paste that into this thing is, there we go. And if I paste that, that will go and take you to the schema definition. So that will explain to you how did we build it out and what was the schema. So you don't, if you use that profile, you don't have to worry about that definition. Um, if you use the custom kind of codes, then yes, you can define your payload format. Normally, we do like a JSON kind of structure of that payload format. And then we've got internal placeholders that we utilize to either replace model attributes or either replace period starts and period ends. So you've got that kind of capability, either complete customize your JSON or use the profile that we've created.
And maybe I would provide just as a base answer, all of the different pieces of the model can be referenced. And when I say all, not all, but the majority of the pieces of the model can be referenced as part of this payload definition. So when you add if you add a limit, if you add a description, your formatting, your periods, your model attributes, all of the things that you've added to this are not lost inside of this product. They are exportable. And that's what's so important about this information layer that we're talking about, because high visibility means high trust. And that's what we're driving at. And then there's a question around the MCP. How's the semantic layer built for the MCP? Great question. Is it only UNS based? Oh, no, not at all.
No, no, no,
So
no, no. Yeah.
the AI Gateway is our product. AI Gateway connects to essentially is two MCP servers, one on Infohub, one on Timebase, that already has all of the tools so that your agent knows how to interact with our databases. You're not, yeah, go
You're
ahead,
not,
Lenny.
yeah,
Take us through it.
you're not building it. So we provide these 22 tools. So these tools already have the description and the semantic layer around what they do and how they do and what and how they need to be utilized within the product. They are served by our flow server. So if I go to my deployment view, if you deploy this flow server, it has an endpoint that has the MCP server already up and running. So you don't have to configure anything. You don't have to make any changes to the model. You don't have to build these tools yourself. We maintain it, and that's why we call it a product, right? That's why we call it the AI Gateway product, because we maintain and handle those tool sets and for you in that regard.
And Mark has a question. I think we'll end it with Mark's question. How can I look to model against a non Part 1 ISA 95 model? Say I wanted to focus on material tracking.
So we don't have any fixed rules around how you structure this model. So I don't have to follow the ISO 95 kind of structure around it. So in my case, I can move this out. I can literally flatten it. I can move this filling line out of there and have it um, underneath any one of these folders. It won't break anything. So I do have that flexibility to move the things around within the model. Um, there's no rule. There's no rule to say I have to have an enterprise or a site or a production. You can create this model as you want. And you'll see there I've just moved out that filling line underneath the enterprise itself. So you've got flexibility there. What we
Re-
are doing in the next in our upcoming release is we are going to be able to give you different views of the model. And that views is going to be able to say, I want to look at my model attributes and I want to look at anything that is under site one as an example. And it will filter and change the view of the model based on how you group your different model attributes together. And that's something that we are working on and that will be available in the next release.
next release should be in the next 60 days. So,
Yeah.
Mark, we'd love to give you a sneak preview. Um, you know how to get a hold of us for sure. So just let us know and we'll take you through it. And then also just Mark, I think this is really the big opportunity for the product that we're also busy on the other side of the house building, and that's Timebase Atlas, which is our knowledge graphing tool that will allow you to build models that are really dependent upon those types of relationships so that you can do more advanced analytics. More of that to come here in the middle of the summer. Well, to our audience, thank you so much. I will just show that QR code one more time in case we could entice you to reach out and have a conversation. You know, we would love that. It's the easiest way you can tell us that we've done a good job and is to let us understand some of the problems that you're looking to solve. We'd love to partner with you on that and kind of walk alongside you. So, Lenny, thanks for sticking with me on a Thursday where you're not feeling so great. You did an awesome job as always.
Thanks.
And to our audience, I say thank you, and we look forward to talking to you soon.
Cheers, everyone.